The year 2024 will be remembered for many things, but one event, in particular, made us look skyward with awe and apprehension. The sun, our reliable life-giving star, threw a cosmic tantrum, a mega solar storm unlike anything we've seen in recent times. This wasn't just any solar flare. This was a full-blown eruption of energy that rippled across the solar system, reaching our little blue planet with a celestial bang. Imagine a billion hydrogen bombs exploding at the same time. This energy, in the form of charged particles, raced towards Earth at breakneck speeds, slamming into our planet's magnetic field. The result? A spectacular light show of auroras, but also some technological hiccups that reminded us of our dependence on delicate electronics in space. The 2024 megastorm served as a stark reminder of the immense power of our sun. It's a call to action for scientists and engineers to develop better ways to predict and prepare for future solar storms. To understand the fury of a solar storm, we need to start with the basics: our sun. This giant ball of plasma is a churning inferno, constantly engaged in a cosmic dance of magnetic fields. These interactions can sometimes lead to a sudden, violent release of energy, a solar flare. Now imagine a much larger pot and a much bigger release of energy. That's a coronal mass ejection, or CME. These are massive bursts of plasma and magnetic field from the sun's corona, the outermost part of its atmosphere. When a CME is aimed at Earth, and it's a big one, we brace ourselves for a solar storm. The sun has its own version of seasons, with periods of high and low activity. During solar maximums, these eruptions are more frequent and intense. A powerful enough storm can punch through, disrupting our satellites, communication systems, and even power grids on the ground. The most visually stunning effect of a solar storm is undoubtedly the aurora. These shimmering curtains of light, often green, red, or purple, dance across the night sky, captivating onlookers with their ethereal beauty. They are a direct result of the sun's charged particles interacting with Earth's atmosphere. But beneath this mesmerizing spectacle lies a more complex reality. These same particles, while creating beautiful auroras, can also wreak havoc on our technological infrastructure. Satellites, our eyes and ears in space, are particularly vulnerable. The high-energy particles can interfere with their electronics, disrupting communication, navigation, and even causing them to malfunction. The 2024 storm led to widespread GPS disruptions, affecting everything from airline navigation to ride-sharing services. Predicting solar storms is a bit like predicting the weather here on Earth, but on a much grander and more complex scale. We know the sun goes through cycles of activity, but pinpointing the exact timing and intensity of a solar storm is still a work in progress. Scientists rely on a fleet of spacecraft that constantly monitor the sun, acting as our early warning system. These space-based observatories track sunspots, solar flares, and coronal mass ejections, or CMEs, providing crucial data that helps us understand the sun's behavior. Even if we detect a massive eruption, it won't necessarily be aimed at Earth. But if it is, scientists can issue alerts, giving us some time to prepare. The 2024 megastorm, while disruptive, was a potent reminder of our place in the cosmos. We are not isolated on our little blue planet. We are very much a part of a dynamic and interconnected solar system. The sun, the lifeblood of our planet, is also a source of potential danger. But rather than fearing these cosmic events, we should approach them with a sense of wonder and curiosity. The study of space weather is a rapidly evolving field, and each solar storm provides valuable data that helps us unlock the secrets of our sun. The sun, with all its fury and splendor, continues to shape our world in ways we are only beginning to understand.